the University of Huddersfield, inspiring tomorrow's professionals.
So this is about using video, and in particular, it's about addressing a particular and kind of paradigm of learning, which is called the idea of learning of mistaken practice or mistaken theories. And it's an idea that's come from the natural sciences originally. Anyway, I'll talk more about that in just a moment. Here's my outline. Start with the idea that video can be a simple and non-challenging thing, and I want it to be challenging and not so simple. And in fact, the research is showing that viewers of videos actually are intelligent in their use, and I'll rehearse some of that. I'll then talk about this mistaken theories idea, and that was the inspiration for this approach. And then in particular, I'll spend a lot more time talking about the two examples I've done. One based on interviewing, one based on correlation. So that's the outline. Okay, so starting with the idea of a video. All too often we think of video as something you simply watch, and if learners watch a video, what's going on here is some kind of simple transmission of knowledge. They're watching the content, they're getting it, and then they're not doing anything active at all. The learners are seen as very passive receivers of the knowledge. And the same said about lectures as well, that there's not much going on here. They're just learning, if anything, what's going on being told. But I think there's more research now that shows that this isn't true. Partly, it's certainly not true of lectures, but it's not true of video either. For example, there's lots of research showing that videos convey a lot more than just the so-called content. For example, the enthusiasm of the lecturer, the hand movements, of course, the pacing in the materials that they give, the explanations they give that are addressing special difficulties and so on. All those kind of contents come in a video that are important. But more than that, the videos also give a kind of sense of embeddedness to things. So we can have real examples, we can have examples embedded in a bigger narrative and so on. So there are ways in which doing things in video are giving some extra benefit to the materials. And in particular, students are not passive, they're active users. And there's lots of research now to show that the way that students use videos is to stop and start, to rewind, to rewatch and so on and so forth. So that they're actively restructuring the teaching materials for their own needs. Now, the second source of the ideas here was the mistaken theories approach, which I say comes from natural science, particularly from physics. And it's the idea that that learners rarely start with no understanding at all. That normally someone trying to learn something new applies some kind of interpretation to what they're doing. They start with a theory, albeit a mistaken theory perhaps. And what often happens, particularly in the natural sciences and in engineering, is that mistaken theory continues because nothing's challenging it. There's no sense in which the theory they have is shown to be a false understanding. As I say, much of the evidence comes from STEM disciplines, and there's been various ways in which that's been approached. I mean, students think they understand, but close questioning of them, or even, for example, working with their peers, begins to reveal these mistaken understandings. And I was surprised to find this even in my own teaching in statistics and social sciences. This is many years ago now. I wrote some software, and we tested it out using verbal protocols. Verbal protocols are where you get users to talk about what they're thinking while they're using the software. And what was clear about this is about using correlation, and they were explaining what they were doing in a quite inaccurate fashion, but on screen doing the right things. So they had a mistaken theory about what they were doing, even though they appeared to be doing the right things on screen. So it's interesting that this was visible in social science students. However, there is evidence that video can exacerbate the situation. Leeuw and other people too have found that actually sometimes videos simply reinforce the mistaken conceptions and don't challenge them in any kind of way. So what I wanted to do was try and challenge them. How can we kind of approach that in a more concrete fashion to challenge the interpretations? So that's oh, sorry, one more on mistaken conceptions. Müller, one of my heroes, he's is he Australian? Anyway, he did his PhD was only in Australia, physicist by background. He's now got his own YouTube channel called Veritasium, which I'll mention in a moment, where he gives a lot of these kind of ideas. But in physics, he demonstrated this very clearly, that students can have mistaken conceptions which are not corrected by being presented with the correct theories. And what he did was present them with the mistaken views and then correct them. So there were various ways of doing that. He got other students to give mistaken explanations and then correct them. And he found that these videos actually did challenge, and the students did learn from it. So the question was, okay, someone's done this successfully in physics. Oh yes, here's one of his videos. I won't show the video, but this one, where do trees get their mass from? The whole idea is, well, we know where well, maybe you don't know. The mass comes mainly from carbon dioxide. And that's what he's trying to show. But he then starts the video by having a load of people talking about it comes from this, it comes from that, it must be from the soil, comes up from the roots, and so on. And it's not, it's carbon dioxide out of the atmosphere. So that's the general principle. So the question for me was, can I apply this kind of idea in the social sciences? Can I apply these kind of things to the kind of work I do with social science students? This is problematic because in the social sciences we normally have a range of theories. We don't have a settled account to give of things. It's very much contested disciplines. And so, in what kind of areas would this make sense? And to some extent, I made it easy for myself by chose to focus on research methods. Because at least in this area, there's more agreement about what the correct view is. Particularly in something like statistics, it's quite clear what the correct view is. So I've taken an easy route, but I wanted to see if I could do this with social science students. So the idea was to use video to tackle these mistaken views, and I chose two approaches. One was a skills-based activity. In fact, it was undertaking research interviews, kind of in-depth interviews. And I did it by videoing interviews and then a tutor pointing out mistakes, pointing out improvements, and so on and so forth. I'll come back to that in a bit more detail in a moment. The second example was based in statistics, and it was understanding this idea of correlation and scatter plots. So it's a knowledge-based approach, and again, there are lots of mistaken views students could have, so I tackled those views and then used a video to address those mistakes that students made. And in this case, I did it by explicitly identifying the mistakes that the students made. So here's the first of those. This is the research interview. It's on YouTube. I think it's had about 30-something thousand views now, so it's proved quite popular. And here's the actual interview being done. In fact, there were several examples of the interviews. I start with a kind of a short lecture kind of thing on good practice. Then we have a bad interview. Then the bad interview is repeated with my interruptions. I stopped the video at various points saying what was going wrong here was so-and-so, what was going, this wasn't right, etc. And then we have a better interview, a different one, a much improved interview. And here I have kind of subtitled, comments as I go through. This was much better. They did so and so. Look at the rapport here. It was done this way and so on. So you get a corrected version of things. Now the evaluation of this was fairly simplistic. Sorry. I've put these in the wrong order. The example I've said all this. That's what I just said. Okay, so the evaluation of this, it's been on YouTube about 2 years. 36,000 views. It's actually had 7,000 more than that because somebody else stole my video and is entered under their name. And they've had 7,000 views, having got my video on their channel. But anyway, that's by the by. Nearly 3,500 views from colleges, universities with embedded the video in their own websites, and a lot of them have written to me and told me about that. And of course feedback in comments and so on. And what was encouraging was the kind of feedbacks I'm getting. Sorry about the square glitches there, it's because I did this on a Mac and the PC is not very intelligent. So we can see these are from students. The video is very enlightening. I become more careful not to make mistakes, so they're clearly aware of that. Sometimes you get carried away and forget important interview good practice. And I think the second one particularly good. The vivid contrast of two examples are going to work in my favour. And the errors pointed. So they got the message anyway, students. And in fact, so did some lecturers. This is a member of staff who wrote to me and said, excellent sample can be used to encourage discussion, demonstrate good practice. So that was the first approach, and that kind of encouraged me to think more constructively about a kind of a better way of answering the question, does it improve learning? And that's what I've tried to do in the second approach with a correlation example. So different example, but using the same kind of principles. In this case, I started with two videos. There are two versions. One of them has these 4 specific common mistakes. So in the video, I actually tackle the 4 mistakes. I say, often students do this and think this or whatever, and here are the 4 mistakes they make. This, by the way, comes out, there's quite a big literature on this, the kind of mistakes that students make in learning about statistics. So there's quite a bit of literature on this, and I picked these 4 things that related to correlation. There was a second video that omitted that explicit reference, so there are 2 versions of the video, and this one didn't have those things where I said students often make mistakes like this and so on, but it had other material to make it roughly the same length. So the 2 videos are roughly the same length, but one had the explicit mention, the other one didn't. And then I could use this in an experiment, which is what I did. I then did an experiment where students were randomly assigned to watch one of these 2 videos. In fact, they started with a test. Then they watched the video, then they did a post-test, and I saw what improvements were made in that design. So I had a 2 groups, pre-test, post-test experiment. So here's the videos, that's me, yes. This is one screenshot from the video. Some of it was me talking. I did actually talk, didn't just sit there, with kind of some bits on the side as well to illustrate the points I was making. And I was lost on the screen, and here was an animated graph showing, how you do a scatter plot and so on, what it all means. Very simple stuff, but it worked quite well. The big problem in doing this is how to measure learning. And I was quite lucky, and I found somebody had done it for me. A woman called Erica Morris, who now I think works for the HEA, but this time she was doing a PhD for the Open University. And she had constructed a whole barrage of test questions about correlation, which she used in her thesis. What she was doing was comparing computer-aided learning with classroom teaching rather than video. So I just borrowed her tests, slightly amended them because, if I said this on the next slide, yeah, she included open-ended and fixed response questions. I just took the fixed response ones. I wasn't so interested in getting some open-ended, well, I am now, but I wasn't at the time so interested in open-ended responses. And by the way, anyway, Blackboard wouldn't allow it. I had real problems implementing the whole system in Blackboard. So I could only use the fixed response questions. But anyway, I had these barrage of questions, which I added to with some questions at the end about other issues to do with statistical significance, which came from a different literature, which she didn't address. So here was the answer to my question, how to test this. So this was how I constructed the 2 tests. And I think this is the results I got. I've given you the slightly cleaned up version here, but anyone who's familiar with means plots in analysis of variance will say immediately, wow, you've got a good result here. Let me just show you what this is telling you. These 2 groups here are the pre-test groups. The pre-test scores, the 2 groups. So the blue line is those students who were doing the experimental condition, which was the video with the specific mistakes in, where I mentioned the specific errors they were making. The control group saw the video that didn't have that in. They just saw a video of me telling them what correlation was, what it meant, and so on and so forth. But I didn't actually mention any particular mistakes. So that's the dotted line. So to begin with, in the pre-test, these were randomly assigned to these 2 groups. In the pre-test, the experimental group actually did worse. They knew less about correlation before they started the video. The control group knew more. But by the end, that position was reversed, and both groups learned a lot. So what I can say is the first score here, the F value is 90 and the P is less than 0.001. That's overjoyed. Gronia's smiling because she knows when our students get that, they think, oh, well, I've got something here. So I can show very clearly that watching my video, they learn something. It's pretty clear. I mean, okay, one can argue about whether this was a good test of learning and so on and so forth, but given that, they're learning something. What I would have liked is for the second one to be significant too, because that's telling me that this difference here is significantly different from this difference here. And judging from the chart, you can see that the experimental group did learn more, and they began to overtake the other group, watching my special video. But unfortunately, with only a small number of students, in the end, only 10 did it. I invited nearly 300 students to do this, and only 10 of the buggers actually, oh sorry, I'm on video as well, I just said that. Only 3 of the very nice people, only 10 of the very nice people actually chose to do it in the end. But I'm hoping to get some more later on this year who can pick it up then. So, overjoyed that I've got a nice result here. A bit kind of dismayed the fact that because the N is so small, it's not significant, and I would like it to be significant. P equals P less than 0.05. But anyway, at least it's on the right lines. I think I've got some bit of evidence here to suggest that at least it's worth persevering with as an approach. So, to discuss those results, I think certainly relevant learning effort produces learning. It's quite clear that by watching these videos, by focusing in on the subject, the students learn something and do better at the tests. Interestingly, Morris found the same in her work. She compared, as I said, the software that she designed with relevant book material and also non-relevant book material. And what she found was that actually either learning software or the book would help the students learn. But doing some reading in irrelevant stuff didn't. No big surprise there really, is there? But she was a bit disappointed. She wanted a bigger difference than he needs to here. But obviously effort helps. Student effort, doing something, they will learn. But what I wanted to show was that certain ways of presenting the video would help them more. Muller has found this in his work on his work in physics. He did find that difference. His videos did make a difference. He could show very clearly that by addressing the mistakes, the students did learn better than they would have done if the mistakes had not been done. But I haven't got there yet. I've still got to get to that. I think that's the last slide. Why? Why that difference? Why did Muller find the difference but I didn't? And that might be to do with the differences between physics and statistics and sociology. In Muller's videos, all the people have kind of common everyday explanations of the mistaken ideas. Now that can't be said of mistaken ideas in statistics. There's virtually no common sense ideas there at all. So that might be one difference. Or it might be just simply the way we did it. I mean, he used young people expounding mistaken views. In my case, it was the old get me, explaining what was done wrong and so on. And of course, that might be different in the way that students internalise that or empathise with or whatever to take on those mistaken views. So, conclusion. I think, I haven't proved it absolutely, but I think like lectures, videos can produce learning gains, and they can help in particular ways to help students learn. I followed all Mayer's principles. He's a guy who's written a lot about how to design multimedia in ways that's good for teaching, and all the videos kind of match up to him, and I think we know that at least. But I think video can go beyond this knowledge acquisition, beyond this transfer of knowledge idea, and specifically tackle real learning problems. But we still clearly need lots more research in how to do that, what kinds of things, what kinds of ways presenting things will make a difference to the students. So I think there's work still to be done on that. And that's it. I'm sorry, I didn't even see if there was a 5-minute one, but I finished early.
I was
Sorry. Anyway, that's it. Finito. Oh, there's some references too, if you can read.
Thank you very much. Questions for Graham, so I can say that bit.
Sorry, Liz.
How determinist was the test? Did you do the test, then they did the video, then you immediately test them? Or
Yes.
was there a time?
Yeah. Yes, it was all done in Blackboard. And the way it was done in Blackboard is they came into it was a modular area I set up actually in Blackboard, and they did the first test. They were then told on screen, the message came up, so now please watch the video, and they were randomly assigned to one of these 2 videos. And then when they'd done that, they had to click another button, and they were then taken into the post-test. And they were told beforehand that that's what would happen. It would take you 25 minutes, and it would be 5 minutes of this, so many minutes of the video, 5 minutes of that afterwards. So, and there were 1 or 2 that didn't do that. They stopped halfway through, and I could tell that because the results come up in grade mark on Turnitin, on Unilearn, so I had to just exclude those data. I only used those that did all 3 stages, and as far as I could tell, it was all very much at the time. I did tell them they could come back and stop things and come back later, but I don't think anybody did. I think they all did it very much there and then in that time slot. Yeah.
That's a self-selecting group in a sense then, because those that
Oh yeah,
they
it's
absent themselves.
This is one of the things about experiments. We often don't talk about that. We randomly assign to different groups, but we very rarely randomly assign to the experiment. And I was taking volunteers from the 200 students. But what was interesting was how low the scores were to begin with. I was gobsmacked at these students, how little they knew about correlation and what mistakes they were making, despite the fact that they were all psychology students, not all, but mostly psychology students, second year or third year sociology students who had all done correlation before. But they obviously forgot it.
That's what Eric Reserve found at Harvard, though, isn't it?
Yeah.
Brightest and the best, supposedly. But,
Yeah.
fundamental errors about understanding physics.
Yes, yeah.
Raised,
I mean, another question to ask about this is how long did they keep that knowledge? Okay, so they were examined directly after watching the video, so they remembered it, but would they remember it the next day, next week, and so on? And so there's another issue there about how long that improvement lasts. Yeah. Sorry, I'm asking my own questions there.
I was just going to ask a similar question about the one about the interviews. Did you set it up in such a way that you said to somebody, do an interview and include these four things? Because I've tried to do sort of good and bad.
I have to say, the two people who did it, one was one of my researchers, he was a research fellow on my project, and the other one was a colleague in the department, a psychologist. And they were both, well, the interviewer was the colleague, and she's very good at doing it. So what we did was say, do something as bad as you can. And they both knew, because, at least the lecturer knew what the...
To set up and make it.
And I had to say that the researcher, who was the interviewee, was very good. I thought to some extent, she was very shy anyway. So some of it wasn't acting. She was actually being very shy and sitting there like this and so on in the interview. But she came alive in the second one. That was a kind of testimony to the skill of the researcher, I think, that she transformed it by asking the right kind of questions and so on. And I could then, obviously, I could comment on, look, notice how this is happening now. Notice how she's giving much longer answers, and etc., etc. So I was helped enormously by having two really good actors, so to speak, in the thing. Yeah.
Do I worry about the ethics of this?
Yeah. What?
The ones that didn't get access to what appears to be the better quality learning experience might have a claim against disadvantaging them.
There are several ethical issues here for that particular part of the experiment. I mean, one is I did it through a system called SONA, S-O-N-A, SONA, which is a system we have in our department where students can actually get credit from doing it. And some of the students that did this got credit from it. So they get 1.5 credits, I think, from doing this particular experiment. So you might think that's ethically dubious, and it may be to some extent, but they're getting experience of what an experiment looks like and so on, and that's part of their teaching. The others were just volunteers on that. I didn't think so much about, I thought, in a sense, this was all in addition to their teaching. So it wasn't part of their teaching, it was in addition to it. So I didn't worry so much about the being left out kind of group. But I think you've got a good point there, because I'm thinking about doing a second stage of this with my second year students who are about to do correlation. And what I might do for them is actually show them both videos, but in a random order. So some of them will get this one, they'll do the before and after, and then they'll get the other video they hadn't seen before, perhaps, or some version of it, so they will catch up in a sense. I think that's a good point to make, yeah.
Could you tell us a bit more about your correlation experiment? How did you
Oh, the original one, years ago, you mean? The one I did with the verbal protocols?
Yeah, so how did you set, the mistaken practice in correlation and then...
Oh, sorry, the new experiment.
Yeah.
Okay, right, well, what I can say, the videos are on YouTube, but they're private, so I'm not sharing them at the moment. But what I did was, it was a very straightforward kind of lecture almost that I did. But what I do with the rest of my videos is I then impose various kind of visual aids on top of the talk. So I had a set of slides I just went through, sat in front of the camera with my iPad actually, on the iPad, just went through them and talked, as I do anyway when I'm teaching. I teach this normally anyway in class. So I just did that. And then I added things to them. So the scattergram you saw, for example, I actually animated that to show how the points are plotted on the scattergram and so on, to what that means, and various other aspects that are using that. So I very much elaborated the visual impact of those. And then for the experimental version, I'd written some extra slides that said these are common errors. And again, that came with the literature. So the common errors were things that the literature has identified as things that students often get wrong here. Partly that was Erica Morris's PhD, partly it was other research that's been done as well on problems of learning mathematics. So I had these, and then what I did then was use my own intelligence, my own understanding. This is where the teacher comes into it, I guess. That actually, I did know, for example, that the reason why some students make mistakes, for instance, about negative correlations, is because they think of negative like temperature, so that -10 is a lot colder than +10. But in correlations, a correlation of -0.7 has the same strength as a correlation of +0.7, and so on. So I could not only explain the error, but the logic behind the thinking that leads to the error, and I tried to do that as well. So that were the extra bits I did in. But then, of course, I had a very long video, so I had to make the other one longer. So I added in some extra bits there, some other slides that made the other one, that was just explaining the same, again, more examples of different correlations and so on, but without explaining any errors as such. So it was a similar length. So is that what you meant to? Yeah.
And you also mentioned about non-linear correlation in one of the slides. In R square value. How was that?
Oh yes. Well, I think what I was going through there, I think that was the control version I had that in. It was just extra examples, and I mean, all I was dealing with is what is called linear correlation. So where you think one variable correlates on a straight line, effectively, with another one, a single, a univariate correlation. But you can have correlations that don't form a linear sense. So there may be a kind of curvilinear relationship, or which is some kind of relationship of power or log or whatever between the variables. I don't deal with that in my teaching. I just want to illustrate that sometimes you can get that, and I think in the examples I had, you can find there's a set, I can't remember his name now, some guy's got a set of data that all has exactly the same correlation, but quite different interpretations of the data, and curvilinear relationship was one of those that was wrong. So that was more detailed content.